Hey, welcome to the first video of the second part of the course. You have left past the first part where you learn the basics of Python and you practice the basics and you learned a lot of the main libraries to build different applications with Python. Now, these applications that we built were mainly smaller applications, but from now on we will build larger applications. And this time we will use another programming paradigm called Object-Oriented Programming, or OOP for short. The programming paradigms we used so far were functional programming and procedural programming. You are using functional programming when you are using functions in your code to process data and return values and so on. So for example, here we use functions in our web scraping app, which we built previously. And then we also use procedural programming, which means you don't use functions at all, you just use lines after lines. So we did that with the other apps as well. So these programs are more linear, which means you get some input and the way to go to the output is quite linear. So you process that input and then you produce some output. But imagine an app where users can book tickets, such as hotel tickets or airplane tickets, and then the user can pay for a ticket, they can use a credit card, they can do other actions such as cancel a ticket and so on. So in such an app there is a lot of interaction between different entities of the program. So between the ticket, the user, the credit card and so on. For such larger programs, you can still use functional programming or procedural programming to build the app, but those two paradigms are not the most efficient paradigms to build such apps. The most efficient way that professional programmers use to build larger apps is called Object-Oriented Programming, OOP. And Object-Oriented Programming uses classes instead of functions to organize the code. So in the next videos you will learn how to use classes to write programs so that your programs are in Object-Oriented Programming style or paradigm. And that is the ultimate way to program, and that will scale up your Python skills, and everything else will make so much sense. So get ready and let's go. I'll see you in the next video. Hi, welcome back. I'm very excited that today you will learn object-oriented programming. So let's begin. To be able to follow this video, you need to download the 3 files in the lecture resources. So that is the data.db file, extract.yml and main.py. These are the files of the previous app, the Scraping Tools SQL app. So please create a new PyCharm project and copy those 3 files into that project, just like I've done here. Now what we will do in order for you to understand object-oriented programming is we will rewrite this app by using the object-oriented programming paradigm this time. So using classes instead of functions. But just before we do that, I want to refresh your memory. I want to quickly explain what this app does. So these are the import statements, and this string here is actually not needed. We just left it there temporarily, but then we forgot to delete it, so we don't need those 2 strings. You can delete them. And so here we establish a connection to the database, data.db, which should be located in your project directory, this one in here. This database file that I gave you has an events table, which is currently empty. Then we have this scrape function. What this does is it visits this URL in here, which points to this website, right? And then this function gets the source code of that page, which corresponds to this HTML code here. And then this other function in here gets that source code that this function returns, and it extracts only this part which sometimes is an event, a musical event of a band. It contains the city and the date of the event. And sometimes this changes, so if I refresh the page, sometimes we have no upcoming tours, sometimes we might have another event playing here, and other times it could be the same event, and so on. This function returns only that value, whatever it is, no upcoming tours or the event. Right, so then, this other function here sends an email. That's what the responsibility of this function is. It sends an email to that receiver email address. That's it. Then we have this other function, store. This other function gets the event, this value, and it stores it in the database using this SQL query here in that data.db database. And this other function reads the existing data of that data.db database. And it returns those data. So it returns the rows, which is like a tuple containing different lists, different values, depending on how many values we have in the data.db file. And this part here is where we call all these functions, which is this here. So we run a loop, and then in every iteration, we get first the source code of the page using the scrape function, this scrape function in here, and then we extract the value, which could be no upcoming tours or something else. We store that value in here, and then we say if the value is different than no upcoming tours, so if there is an event on the page, then we read the existing events from the database using the read function. So we return the existing event. We see if we have stored that event already. If not, if there are no such events, then we store the event because the event doesn't exist in the database, so we store it. And then we send an email to ourselves, letting ourselves know that there was a new event in the website. A new event which was not in the database, and so we should know about that. That's what this app does. Now, we can rewrite this using classes. So let's do that. Let's install these packages first, request and selector lib, so we get rid of these underlines. And let me create the first class. To do that, please select these two functions, scrape and extract, and then press Tab. Tab will indent those functions with 4 space characters. And then create some space in here, and on top say class, tool, or event, whatever you prefer. I'll just leave it event. And then in the function parameters, you need to add self as the first parameter, comma, followed by the other parameter that the function already has. Same for this, self and that. And have another break line here because that's what it is recommended to have. And here you need 1 break line. So this is not mandatory, but it's a good practice. So 2 break lines after the class definition, 2 break lines before the class definition. So this here is a class definition, or just class for short. And a class is made of functions. So this class here has 2 functions, scrape and extract. But we don't use the word function anymore when we are working with classes. Now these 2 are called methods, actually. So we have the extract method and we have the scrape method. So these 2 methods belong to the event class. Later I'll explain you what self is, but for now you can just ignore that and you'll understand it later what it is. Now you would ask, well, why would we use a class? Why not just leaving those functions as they were? Well, but as you can see, this gives us a better way to organize the code because we have so many functions here. So it makes sense that you categorize them into classes. So these two functions, basically, they belong to the event class because they scrape the page that contains the event and then they extract the event. So it's a good idea to place them inside a class called event. Now, you can also name this class like that, it is possible, but it is not recommended. And also, PyCharm will tell us that class names should be camel case, which means starting with a capital letter, and if the word has two parts, like it could be good events, then you use a capital letter in here, no spaces or underscores, but a capital letter for the second name. In here we only have one, so let's just keep it event. Right, so that's the class definition, but now we need to change the way these methods are called here. So currently we still have them behave like functions, and PyCharm is telling us that, oh, there's no function with the name scrape, which is true because scrape is not a function anymore in the global namespace. Now this function is a method and it belongs to that event class. So before you call that method, you first should create an event instance by calling that class. So the way you call that class is like this: event, the name of the class, followed by parentheses. So this is similar to how you call a function. Later you'll also see that classes can also get arguments like functions do, but for now let's just focus on calling a class without arguments. And then event will be the variable where the instance of the class will be stored, right? So you can have many instances now, like event1, event, event2, event. And when you learn about arguments, you'll see that these different events can take different values for the arguments and so on. So let's just ignore multiple instances for now. For now, you should know that this creates an instance, and without parentheses is just a class. So once you create an instance, an event instance, then in here you should point to that event instance. So you see event with lowercase letters. So we point to the instance. Dot scrape. Same goes for extract. Extract is also a method of the event instance. So event.extract, event.scrape. And if we run this code now, it will work exactly the same as it used to do when we had functions in here. So the functionality of the code doesn't change when you use object-oriented programming. What changes is the structure of the program. So object-oriented programming is good for you as a programmer or for your collaborators, other programmers who are collaborating on the same app, because it gives you a well-structured app which is easier to extend later and it's easier to modify. Now PyCharm might give you some advice here. Maybe this method is static, it says, but feel free to ignore that. We'll talk about static methods later. Now, we can do the same with this send email function. So the idea is that when you use object-oriented programming, every function is categorized in objects or classes. So we use the term class and object interchangeably sometimes. That's why it's called object-oriented programming. So your code is built around objects. The first object we created was event. So that's the object, and then this is the object instance here. So it's an instance of that object. When we create later a ticket class for a hotel reservation app or an airplane reservation app, then ticket will be one class, but users will create multiple ticket instances, right? A user will create their own ticket using that class, that blueprint. Another user will create another ticket and so on. So that is one object, and then the other object would be class email. And this class would have that method. So select that, press tab to indent it, make a break line here to have 2 break lines here and 2 break lines in here. And so this class now has a send email method, which perhaps we can rename this into send. Why did I rename it? Well, because let me show you why. So we go here then, and we don't call the send email function, but we say email. We create an instance of the email class, which we just created. And then in here we say email dot just send. So it makes more sense to say email dot send than email dot send email, right? So by using classes now, you have more freedom to use shorter names. So now you know that this send method belongs to the email class, so things are more categorized. Yes, we do have some longer code because we added a class here, right? This line, and then we add the instantiation part of the class here and here as well. But longer code doesn't necessarily mean worse code. The code should be readable and it should be extendable. That is what makes good code. And that's about this video. In the next video, we will work on creating a class for these two. The process here will be a bit more advanced, and that is where you learn about the init method, which is a special method, and also about self, which should also be here, by the way. So self should be in every method of the class, most of the times, because sometimes in special cases you might omit self, but that's a special case which we will cover later on. So that's about classes in a superficial level, but we have a lot more to cover. But for now it's enough to remember the syntax of classes, and let's move on to the next video. I'll see you there. Hey, welcome to a new video on OOP. So far we created 2 classes in our event scraping app, an event class and an email class. Now we have 2 more functions which are floating around without a class. So since we decided to make this an OOP app, then it's a good idea to place all the functions inside classes. So what do you think should be the next class we should have here? So we have a store function and a read function. These 2 functions are working on a database. So this stores data in the database, and this other function reads data from the database. So I think that these 2 should belong to a database class. So this is just a name I decided to give to this class. You can also call this database table or another name, so you should try to give your classes meaningful names. I'll just leave it database. Make some break lines in here. Add the self argument to each of these. I'll cover today what self is. Now this class here is a bit more demanding than the other 2 classes. This class is also using this connection object in here. So first we establish connection here, and we store that connection in this variable, and then this class is using that variable. But it's a better idea to have that expression inside the class, since we are using classes now to organize our code. Then what I'll do, I'll just cut this out from here. And where do we place that? So we have 2 methods, the store method and the read method. And both methods use that connection variable. So one way is to have that expression in both methods, here and here. But this is not the recommended way to do this. We should place this expression somewhere where it is accessed by the two methods. So just once instead of having repetitive code like this. So I'll delete it from here, and I'll add a special underscore underscore init underscore underscore method. So make sure that the method is named exactly like this: underscore underscore init in lowercase letters underscore underscore. And this also has a self argument as well, and the colon, and then the body of this method will be that expression. Connection is equal to SQLite.connect data.db. Now, this variable then should be accessed by the store and the read functions. Currently though, PyCharm is giving us a clue that these methods do not have access yet to this connection variable. You see, it's underlined in red. It says unresolved reference connection. So basically this function, this method doesn't see that variable. To make that variable visible to these two methods, what we do is we add self dot in front. So now connection is a property of the self argument. And then in here we do the same: self dot connection, self dot connection. So now we point to that property, to that variable, which is a property of self. And so self is like a special variable, and all the methods have access to self, right? So we use self as the middleman to access variables. So self.connection, self.connection, same goes in here, self.connection, and so on. And then when we call the class here, down here, we say if extracted and so on. We create a database instance using the database class, which is with a capital D, right? This class. And then in here we say database with lowercase letters dot read, and same here, database dot store. And if you run the code now, it will work the same as it did before. Now, perhaps your data.db file has some data already, so make sure that you have an empty data.db file. Perhaps you need to re-download it from the lecture resources in the previous video, so that you have a fresh, empty database.db file, and that will send you an email if that's the case, when a tour is found, an event is found. But I guarantee you that this code works the same as it used to do when it had functions in here. Now, if you remember from the previous apps where we used to create PDF reports, we used to have this line of code. PDF is equal to fpdf, where fpdf was a class, so a class which created PDF instances, and this class got some arguments, such as an orientation argument, which was P or L or portrait, something like that. So this class used to get arguments, but our classes here, database, event, and email, they don't get any arguments. But we can also have them make it possible that they get arguments. So let's do that with this database class. And then I'll explain you what self is and what the init method is exactly. So if you want this database class to get an argument, you want to add that as a parameter of the init function or the init method. So the parameter could be, for example, database path, right? And so this goes in here as well, database path, right? And then when you call the class here, let me fold this function and this one in here. So I'm not deleting them, I'm just making them invisible for now. So the code is still there, right? Just want to do that so you see the class and also these lines in here. So now in database, we say database path is equal to the value, which is the string data.db, which points to this file. So now this class is getting an argument. So that's the argument and that's the value. So the way you give arguments to a class is by providing a parameter in the init method. So what is init and what is self? Let me explain these two very delicate concepts now. Init is a special method, as I told you already. Why is it special? Well, it is special because this method is executed when you create an instance of the class. So specifically, when the interpreter runs this line here, this init method is called on the background. So perhaps if you had like a print function here, hello, and you execute this code, that hello will be printed out when the interpreter reaches this line here, right? And you'll get hello in the command line. So I can also prove you that by opening the console here, class foo, just a dummy class, define an init method with self and no other arguments, but just print out hello like that. And then another method define do something with self, print I am the do method, execute, create a new instance foo1 equal to foo. When I execute that now, hello will be printed out because this line here, as I mentioned, executes that method, but this other method is only executed when you point to foo1 and then to that method explicitly. So execute that and you'll get I'm the do method. Now what is self? Self is a special argument. So we have a special method and we have a special argument self. Self actually is the variable which holds the instance that is being created. So, for example, in the foo class here, this is an instance, right? And we can have multiple instances such as foo2 is equal to foo, right? So we have a foo1 instance, we have a foo2 instance. You'll see that these have different addresses in memory. So you see that this has this address, this has another address. These are just random IDs that are assigned by Python. But I'm trying to tell you that these are like different objects, different instances. And so self is like the variable which holds the instance inside the class. And so when you say self.connection, you are pointing to the connection of that particular instance. Let me try to explain it better. I know this is confusing. So let's create another class. I'll use app arrow key to call this previously executed statement, so the class, but this time I'll go up here and I'll add a new argument. Let's say x, right? And then I'll say self.x is equal to x. Execute. Now foo3 is equal to foo with x being 1 and foo4 is equal to foo again with x being 2. Now foo3.x gives you 1 while foo4.x gives you 2. So that proves my point that foo3 and foo4 are different instances. So you can try to imagine this like being the self argument. But outside the class, it's not called self, it's called the variable name which holds that instance. But inside the class, it's self. So basically foo3.x is self.x. So when the user gave the x value to x here, that value went in here first, so x is equal to 1, right? And then self.x is equal to 1. So this x here is that x, right? So 1 is assigned to self.x. So that's the property of self, and that's just an argument. It's a bit confusing, but that's why we have applications, and you'll see how you'll use self in different scenarios, and that will become second nature to you. But for now, this is what you should remember. So let's make a revision of what we did in this video. So you learn the init method, which is executed when you instantiate the class, when you create an instance of the class. So init is executed in here. And then we have self, which is a variable inside that class, and it holds the instance that the user is creating. And then we have other methods such as store and read. And then we have properties such as connection here or this X here, right? That's a property and that's a method. And that's what you should remember for now. So these are concepts that we will revise again using different examples. So don't worry if you don't get things right away. And I'll talk to you in the next videos. See you.